here asks us if we can identify the functional groups that are in this molecule. So if you're not sure what functional groups are, go back, watch some of the older videos. Hopefully you've already learned it in class. Also hit that subscribe button so you can get more of these videos so you can ace your exam in organic chemistry. We're just going to jump right into this. So there's a couple off the bat that I see, but I'm going to actually redraw this first because I don't like this style of notation, but it's perfectly fine if you do. And then also for your exam, you should be able to do this in either way. Or you can do what I do. Here's where I'm going to redraw it, whatever helps you. Just make sure you always give your answer in the format that your professor asks for. So you don't have to argue about if you're getting full credit, etc. So CH2, uh, CH3, and then we have this here, and this. This is the way that's easiest for me to see it. But remember, you should be able to do it in both ways. So I'm just going to go top to bottom. So the first thing we have here, we have this double bond, or it's known as an alkene. Alkene. This is the easiest one to identify. It's just a double bond. It's carbon, double bond to another carbon. The next one we have here, and this is sometimes a little hard to see in this style of notation. It's easier to see it with like stick and line. That is an ether. That is where you have a carbon single bonded to an oxygen, which on the other side of that oxygen is another single bonded carbon. You'll see those a lot, usually used as solvents. Third this is also pretty easy. We see this right here. If it was just by itself, it'd be a benzene ring, but the overarching class is called an aromatic ring right here. And it's important to see these electrons in this pi, they're not actually sitting there in discrete bonds. They're all delocalized, zipping around there, which is sometimes while you'll see it, like with instead of the lines, you'll see the in a circle like representing the delocalization of those electrons. Lastly, in here we have the aldehyde, and this one's a little. This is why I don't like to see it in this notation. I think it's a lot easier to identify when it looks like this. But this is where we have a carbon, which is double bonded to an oxygen, and then it also has a hydrogen on it because if it had another carbon on the other end of it, that would be a ketone. Okay, guys, I hope that was helpful. Remember, functional groups are really important in organic chemistry. Whether you're going on to do chemistry or biology or pre-med, functional groups are what give molecules their biological function and what makes them do things to the body. So it's really important to know them, not only just to do good on the exam, but to actually have a functional understanding of what these molecules do.